here we have a diagram of a motor unit, which consists of an action potential or an alpha motor neuron, dendrites, axon hillock, axon terminal, myofibrils, and then we have muscle fibers. Now, muscle fibers are this gray square. The myofibrils are actually inside of the muscle fibers. The axon terminal connects to the muscle fibers through motor end plates. And here we can see that the action potential travels down this chain and it latches on, which leads us to the next diagram. Now on the next diagram, we have the motor neuron itself. The ball looking things are the storage vesicle, and out of the storage vesicle comes ACH. Now, this gap in between the motor neuron and this is the muscle fiber. So, yeah. So this gap in between the motor neuron and the muscle fiber is called the synaptic cleft. So basically, these storage vesicles in the motor neuron empties out these storage vesicles that contain the ACH, and the ACH then goes to the ACH receptors, which those are really tiny and I didn't know how to draw, but basically the ACH receptors are down in here. And so it enters in. The dots are ACH. And yeah, so that's like the first kind of stage. Next we have, on the next diagram, it shows the terminal cyst array, the T-tubules, so terminal cyst array, T-tubules. We have the sarcoplasmic reticulum, and in this, we have that the dots are the calcium. So basically what happens is, whenever the ACH binds, an action potential is generated in the muscle fiber, and that action potential actually triggers the release of the calcium. Sorry, my mind blinked. And the calcium is actually released from the terminal cyst array, and it goes into the sarcoplasm, and the sarcoplasm is this thing right here. So it enters into these tubes, pretty much looking things. And on the next diagram, we're going to be talking about how the calcium actually binds to troponin on the actin filament, and the troponin pulls the tropomyosin off the active sites and allows myosin heads to attach to actin filaments. So here we can see another crude drawing. So based off of my understanding from the book, the calcium kind of like, I guess, floats down to the active, or not to the active site, but it kind of just floats down, and it kind of like, it binds to the troponin. The troponin is like this little gray squiggle, and the gray squiggle has actin sites, or actin, and it also has tropomyosin on it. And the actin kind of oh shoot, I lost my notes. So okay, the myosin head attaches to the active site because the calcium, it kind of like pulls the myosin off the sites. So I guess I misread the diagram, but the tropomyosin is pulled off because of the CA2, which allows the myosin head to reach the active site. And whenever it reaches the active site, if it binds strong enough, and whenever that strong binding is complete, the myosin head tilts, pulling the thin filament past the thick filament, and the myosin head actually binds to ATP and ATP ACE, and on the head it splits it into ADP and P, which equals energy after a signal is received from the neuromuscular junction. Contraction ceases, and then calcium is then re-uptaked into the terminal cisternae. One thing that I forgot to mention is that the calcium, I believe, misspoke again. So the ACH, which is, so the ACH actually acts as it opens the gate, which is how it's able to bind. So yes.